Okay, guys, so we're on slide 6. We're continuing to talk about equality, the golden rules. Remember, golden rule in life is treat others the way you want to be treated. Golden rule in algebra is do unto one side as you do unto the other. And so all of these equality rules are going to seem like pretty common sense. But it's like how if you have to justify your reasoning in math, you could say, I can do this because of that property. Okay? So the first one, addition and subtraction property of equality, states that adding and or subtraction actually subtracting a common value to two equal values retains its equality. So if A, B, and C are real numbers and A equals B, then A plus C must also equal B plus C.
Letters? You said it was numbers.
They represent numbers, don't they? Symbolically? Mm-hmm. And also A plus negative C is equal to B plus negative C. So in other words, if I'm going to add something to one side of an equation, I must add it to the other. If I'm going to subtract something from one side of the equation, I must subtract it from the other. Everybody should be on this page, right? And then also the same can be true for multiplication and division. So that if we multiply and or divide a common value to two equal values, it retains its equality. So if A and B and C are all real numbers and A equals B, then A times C must also equal B times C. And A times 1 over C must equal B times 1 over C. Remember, mathematicians prefer to use addition and multiplication, right? And so instead of dividing by C, we can call that multiplying by 1 over C.
Byron?
Okay, square root property of equality states that taking the root of two equal values retains its equality. So if A and B are real numbers and A equals B, then the square root of A must equal the square root of B. So when you use this when solving an equation, you pretty much have to get down where you have one term equal to another term. Because if you're going to take the square root, you must do it of the entire side. You can't pick and choose which terms you're going to do it. So if you're going to do it on the right side, you're going to square root the whole side. And then the left side, you have to square root the whole side. You can't be like, oh, I'm just going to do it to this number and that number. Okay?
I don't get how you explain this.
Well, we talked about it the other day when we did the inverse operations, right? Right here. When we took the square root, didn't we take the square root of both sides? That's all that property is saying. That in order to maintain the equality, if you take a square root over here, you have to take the square root over on the other side as well. Okay, the reflexive property of equality. What do you think of when you think of reflect? Many of you guys may have looked at one this morning. The mirror, right? A mirror image. So the reflexive property of equality states any number or numbers, and these for whatever reason moved over, so we got to slide them over, are equal to themselves. So for any real number A must equal A. Now keep in mind that also plays out to be, if you know, for example, different ways to represent something, because we've talked about exponential form, we've talked about scientific form, we've talked about radicals, that also holds true. So 4 can be equal to 2 to the second power, or 4 can also equal the square root of 16, right? So any of those things are interchangeable because they're equal values. Okay, questions on these equality properties? Okay, now go on and talk about the inverse properties. So the additive inverse property states that a number added to its additive inverse, the sum of the numbers is 0. So they're just letting you know that the additive inverse of something is its opposite number. So if you have a positive 2, its additive inverse would have to be a negative 2. And when you add those two together, you get a 0. Because when in math, if we want to eliminate something, if we want to eliminate addition or subtraction, we're trying to get that to a 0. If we want to eliminate multiplication or division, we're trying to get that to a 1, right? So to find a number's additive inverse, we multiply the number by negative 1. Remember, every time that goes off, you guys get another 15 seconds after the bell. So right now you guys are up to 45 seconds.
How?
Because we've heard that 3 times. That's 3 times 15 is 45. So multiplicative inverse states that a number multiplied by its multiplicative inverse equals 1. We're up to a minute.
Oh.
So it says if A is a real number, A times 1 over A equals 1. The multiplicative inverse is called the reciprocal. Muskegon likes to call it the refliprical. Because to get that inverse, you flip the number over the fraction bar. So that kind of begs the question, what happens if there is no fraction bar when you're looking at a number? Well, if you're looking at a number that doesn't have a fraction bar, that means you're looking at a whole number. What number can any number be put over and still be itself? So in other words, you have a 7. 7 over what number would still be worth 7?
1.
1, right? So if you have a whole number envision it first as a fraction, so you're going to put it over 1, and then its reciprocal, you can flip over. So the reciprocal of 7 is 1 over 7, right? Same way if you start with, say, 1/6, if I do the reciprocal, it's going to be 6 over 1, which I can simplify to just be 6, right? 6 divided by 1 is 6. And these are important to know because we talked earlier about the fact that mathematicians like to use addition and multiplication. Right? We kind of don't use subtraction and division. So if we're not going to use division, we have to think of that reciprocal or multiplicative inverse when we're trying to get rid of the coefficient. And the last one on this side is called the zero product property. We call it the ZPP. And it states that if A times B equals 0, then either A or B must be 0. Or A and B both equal 0. Because think about what multiplication means. Multiplication means a repetitive addition of a group. So if you have 3 times 0, that would be like saying you have 3 groups of 0. So if you got nothing, nothing, and nothing, what's that going to add up to be? Nothing. Think of the opposite. If you have 0 times 3, that's like saying you have 0 groups of 3. Right? In other words, you got no groups. So it's still nothing. Okay? So anything multiplied by 0 is going to wind up being 0. Okay, the last one. We're going to be talking about the commutative property and the associative property. And this kind of makes a little bit more clearer why mathematicians like to use addition and multiplication. Because both of these properties don't work for subtraction or division. So that's why they like to focus on the addition and the division. You can change subtraction to addition and division to multiplication. So commutative property of addition, when I think of this, I think of a community. How many people are there in a community?
50 million.
Well, it could be a lot. How about, can you have a community of 1?
No.
No, so it has to be more than 1, right? In order to be a community, you have to have more than 1. So that states that
669,669.
So commutative property states that if the numbers are added in any order, the total will be the same. So if A and B are real numbers, and A plus B equals C, then B plus A must also equal C. So in other words, when you're just adding numbers together, you're allowed to change the order in which you add stuff, and you're still going to get the right answer. So this becomes that part of like when we have subtraction, if we take that and change it to addition and flip the sign of the term afterwards, that allows us to decide which order we want to add it in. And the commutative property of multiplication states that if numbers are multiplied in any order, the result will be the same. So if A and B are real numbers, A times B equals C, B times A must also equal C. So 2 times 3 is going to equal 3 times 2.
Wow. Cool, man.
Okay, associative property of addition. Have you guys ever heard the word associate? Like if I said, who does Alex associate with? What am I asking? What am I asking? Who what?
Who he talks like?
Who are associates? Who he hangs out with, right? Yeah.
He said the mafia.
Well, yeah, mafias. you know, they were the type of groups that hung out to each other, but
You know,
I would think you have, like, for example, you associate with Elijah, right? So, so associate property of addition states that when two or more numbers are added, the result is the same regardless of the way the numbers are placed or grouped. So if A, B, and C are real numbers, and A plus the grouping of B plus C must equal the sum of A plus B plus C.
I'm sorry.
And the associate property of multiplication states that when three or more numbers are multiplied, the result is the same regardless of the way the numbers are placed or grouped. So if A, B, and C are real numbers, and A times the product of B times C must equal the product of A times B times C. So in other words, if you have just addition going on, right, you can relocate your parentheses. And that's kind of how you tell the difference between the commutative and the associative. In the associative, you must always have grouping symbols being used. Okay? In the commutative, you can change the order of the terms, right? You can move them around. In associative, your terms are going to stay in the same order. What's going to move are your grouping symbols. So if you look here, A, B, C, A, B, C. The order of those terms didn't change, but what was placed in or inside or outside of the parentheses did. Versus when we did commutative, the actual order changed. So A times B versus B times A. Okay, that's how you tell the difference.
Wow.
Okay, other questions on the property?